In this video, we're going to talk a little bit about what it means for triangles to be similar and what it means for triangles to be congruent. That would be the focus. And then how we can or cannot prove that triangles are congruent. So first, I want to talk to you about briefly what it means to be similar. One thing that we know about similar triangles, and this is the symbol for similar, the tilde, but without any equal sign, is that all corresponding angles are congruent. So these are the angles. If I knew on this small triangle that I had two angles that were each 60 degrees, then I could figure out the third angle because I know all three angles total 180 degrees. So I could say 180 minus, and if I added the two 60s together, I get 120. So then subtract from 120, I would get 60. That means that this third angle would be 60. The same thing would be true over here. So that means that our corresponding angles are all congruent. That means that the figures are similar. Figures are similar when they are the exact same shape, but they don't need to be the same size. The other thing that's true about figures that are similar is that there will be some kind of scale factor that will allow us to go between figures. So if each of these side lengths were 3, 3, and 3, and each of these side lengths were 12, 12, and 12, then I could see a scale factor going from small to large, which would be multiplied by 4. 3 times 4 is 12. And then to go from large to small, my scale factor would be 1/4, because 12 times 1/4 equals 3. So that's similar triangles. On the other hand, congruent triangles, not only are they the same shape, meaning they have the same angles, but now they have to be the exact same size as well. So now we want to talk about how we know if triangles are congruent or not. And we'll start with this example: angle, angle, angle. That refers to 3 sets of corresponding angles that are congruent to each other. Does this tell us that triangles are the exact same size and shape? No, because this equilateral triangle is smaller, this equilateral triangle is larger. So angle, angle, angle does not prove that triangles are congruent. Now I want to take a minute to show you why side-side angle does not work to prove that triangles are congruent. So when we say we have side-side angle, that means that we have a corresponding side with a corresponding side. So in this case, 6 with 6, 11 with 11, and then the 30-degree angle with the 30-degree angle. That's side-side angle, where the angle is not included in between the two sides. The reason this doesn't work is because this angle is not fixed. We did not talk about this angle being congruent to this one. So what that means is that if we have side-side angle, then this triangle would also be side-side angle with this one, side-side angle. Because this 6 still corresponds with this 6. This 11 still corresponds with this 11, and this 30 still corresponds with this 30. But now you can clearly see, if I erase a bunch of this stuff, you can clearly see that the triangle on the right is much smaller than the triangle on the left. So it is neither the same size, because it's smaller, nor is it the same shape, because this angle is not the same as this angle, and this angle is not the same as this angle. So this is a reminder that side-side angle does not prove that we have corresponding triangles. Now let's review the congruence postulates that do prove that we have congruent triangles. And you'll remember that they are side, 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 angle, angle, side, where you have any two angles from both triangles and you have the third side, angle, side, angle, and then finally side, angle, side. If you want to see examples of those, just real quick, Google them. They're very common, and those are the easiest part of triangle congruence. The last thing I want to bring your attention to is if you have two congruent legs. And what we mean is congruent corresponding legs. Two congruent corresponding legs. So that would mean if you had this 6 corresponding with this 6 and this 3 corresponding with this 3, would you have congruent triangles? The answer is yes. There are two ways to look at it. One way is to see that if these are legs, then that means that this must be a right angle. And if this is a right angle, then it's congruent for both triangles. And at that point, you have side, angle, side. Side, angle included in the middle, and side. So that's one way you know that if you have two congruent corresponding legs, you have congruent triangles. On the other hand, you could think of this as a Pythagorean theorem thing. So if this is a hypotenuse and this is a hypotenuse, then in both cases you'd have h squared equals short leg square plus long leg square, where you have a 3 here and a 6 here. So then what you get here is going to be the same whether you do it for this triangle on the left or this triangle on the right. So the hypotenuses will be the same. And these will actually end up being, you could figure it out, square root of 45, which is the same thing as 3 radical 5. But the emphasis is that if we have two congruent corresponding legs, that means we also have right angles, and we have side, angle in the middle, and side. So yes, triangles are congruent. And the last thing we need to address is, what about triangles that have the same area? Are they necessarily congruent? And here we're going to prove they are not necessarily congruent. They could be, but we don't know that they are. For example, to find the area of a triangle, we have 1/2 times base times height. So here we would have 1/2 times a base of 8 times a height or altitude of 2. This would be 1/2 times 16 is 8 square units. On the other hand, if we had a right triangle with 2 legs each equal 4, then we would be able to say that this is 1/2 times 4 times 4. This would be 1/2 times 16. So again, this would be 8 square units. So even though the areas are equal, they are not congruent because they are not the same shape. Here, these would be 45-degree angles, and this is a 90-degree angle. And then in this case, you'd have an angle here that would be more like 120. I'm not sure what it would be exactly, but it would be much more than the 90. And if this were up to be 120, then these would each be 30. That's if we drew it like an isosceles triangle. What we're saying is, even though the areas are equal, these triangles are not congruent.